so we are going to go through the answers to our page 541, which was section 8.1. So the first two here, we were asked to find the geometric mean between the pair of numbers. So we're looking for the geometric mean. Our x's go there. Our two numbers, 81 and 4, go here, and we simply cross multiply and then square root. 324 is a perfect square. The square root is 18. For number 11, geometric mean, our x's go there. This time between 36 and 24. Cross multiply. This time we have to take out the perfect square of 144, so there's a 12 there, and it leaves us with x. So first two, just practicing geometric mean, and now we're going to be using some of that information to be able to figure out missing parts of triangles. Let me move this up a little bit here. Alright, in number 20, we're asked to find x, y, and z. And so when I looked here, I immediately saw that this was the altitude. And so this, I can set up a proportion and say that my altitude is here for my geometric mean, and then 4 and 6. So I'm going to take and cross multiply, get y squared equals 24, and that has a perfect square of 4 in that, so that's 2 times the square root of 6. So I now know this value here, and so since I know this value and I know this value, I can use Pythagorean theorem to figure out the x, which is the hypotenuse. So I'm going to have that x squared right here is equal to 4 squared plus 6 times the square root of x squared. So that's what I've set up over here. Done my squaring and combine my numbers, and I get x squared equals the square root of 40, which has a perfect square factor of 4, so that gives me that x is equal to 2 times the square root of 10. Now the only thing that I have left remaining is this z right here, but I do know, looking at this triangle, this right triangle, that z is the hypotenuse, and that I know that y is 2 times the square root of 6, and I know that this leg is 6. So up here in red, I have set up my Pythagorean theorem, and you can see that z then is equal to the square root of 60. 60 is a perfect square factor of 4, so that becomes 2 radical 15. Alright, if we look at the next one here, number 21, very similar type problem. We're asked once again to find x, y, and z. This time the first thing I looked at in blue was that if I have this side here is 14 and this side is 5, then I'm missing this z. And so that's a leg. So z is a leg, 5 is a leg, 14 is the hypotenuse. And so I can then figure that out, that z is going to be the square root of 171. And you can see that down here that they gave me the decimal approximation. Once I know, or looking at the given information, I can see that what I have here is a geometric mean with a leg. So here is the leg, 5, and so I put that there and that there. And then here's the side touching, the part touching, which is y, and then 14. And I'm able to cross multiply and divide. I end up with 25 over 14. Here's the decimal equivalent. And then our last one, if I know that when we're looking at this problem here, that I'm looking for x, and if I knew that this whole thing was 14, and I knew that y is approximately 1.8, That 1.8 went there, and then this must be approximately 12.2, and so that went there. And if I take and cross multiply and then square root, I get approximately 4.7. Okay, looking at number 22, starting with the blue again, I saw that, I saw that if this is the altitude here, then this would be, I didn't know that that was 40. At first I would say that that's my geometric mean there, 20 and 20, and that's going to then, the x is going to go here and the 10 is going to go there. That gave me that x was 40 when I cross multiplied and divided. What that helped me do then was if I looked at this triangle right here, I would know that what I have is a leg, so that's 40 squared, and a leg, that's 20 squared, and I'm looking for the hypotenuse. And so that's what I've done over here in green. I get z squared equals 2,000, which has a factor of 400, so that gives me 200 times the square root of 5. I then have enough information. If I look at this triangle right here, I can see that 10 is a leg and that 20 is a leg, and I'm looking for the hypotenuse. And that's what I found there in the red by using Pythagorean theorem. Alright, let me move back up to the top. Alright, so looking at problem 23, I started by looking at the blue, and what I noticed was that if I look at this triangle right here, that the leg hypotenuse, and so I could say that y squared plus 4 squared would equal 12 squared. And when I solve that, I get that y is equal to 8 times the square root of 6. 8 times the square root of 2, excuse me. So that right there then is my altitude. And so I can put that in as my geometric mean. And then the z and the 4. So z goes there, 4 goes there. Cross multiply and divide, and that gives me that z is 32. So now at this point, I know that this is 32. I know that y is 8 times the square root of 2. I'm looking for x, which is the hypotenuse. So I'm using Pythagorean theorem, which is down here in red. Next couple, or we are just looking for the geometric mean. So I'm putting x's there, and then I'm putting the numbers 1/5 and 60. And remember, I could have 60 and 1/5. That doesn't matter because we're going to cross multiply, and I'm going to end up with x squared equals 12, and have to then simplify that radical to 2 times the square root of 3. And these next 27 and 28 are going to be very similar. Looking for the geometric mean. And so then my number, one goes here, the other one goes here. Probably the biggest thing here is when I take and multiply these, 3 times 5 is 15. And then if I multiply the square root of 2 times the square root of 2, that would be 2. 15 times 2 gives me that 30. And then 7 times 7 is 49. And then when I square root, the denominator square has a perfect square, so that gives me a 7. 30 doesn't have any perfect square factors, so it's going to remain the square root of 30. If we look at the next one here, x here and x here, one number here, one number here. Same thing with this one, 3 times 5 is 15. The square root of 5 times the square root of 5 is 5. 15 times 5 is 75. 4 times 4, that should give me, let me correct that real fast. should give me a 16. Probably doing that part in my head. And then the square root of 75, 25 times 3 becomes 5 times the square root of 3. The square root of 16 is 4. Okay, if we look at the next one here, number 29, we're back to finding x, y, and z again. And so first thing I notice is that if I look at the large triangle here, that I know the hypotenuse and I know the leg, and so therefore I could find the other leg by doing Pythagorean theorem. So I can find out that z is 3. Okay. Once I know that z is 3 right here, what I have is a geometric mean leg. And so the 3 is going to go there, and then I'm going to have x, and then 2 times the square root of 3. Now, right here, when I cross multiply, and then I'm going to divide, what happens is I'm left with the square root of 3 in the denominator, and right there is where I have to rationalize the denominator. Remember, rationalizing just means to multiply by 1, and that form of 1 changes every time. So based on what's in the denominator, here it's the square root of 3. So our form of 1 is the square root of 3 over the square root of 3. And then what that does is when we simplify, it removes the radical from the denominator. And we know that that is not, we're not allowed to have a radical in the denominator. And then our last part, looking for y, what we would know is that we would have, looking at this triangle here, we would know that we would know what x is, and we know what z is, and so we're looking for y. So we're using the Pythagorean theorem, and there's our Pythagorean theorem. Alright, if we look at the next page here, I'm actually going to pause the video and do that in a second part just so we don't run too long. So I'll pick that video up in a part 2.